Every night, the universe folds itself into silence, and space feels simple. A soft, three-dimensional room we move through without thinking. But beneath that quiet surface, physicists whisper of hidden corridors, invisible directions, and secret rooms tucked just beyond our senses. Dimensions we cannot see, cannot touch, yet may be woven into every breath of reality. Tonight, we drift toward those unseen spaces. Welcome to AstraFlow. Here, science drifts like starlight, and curiosity becomes calm. Tonight, let your thoughts slow down, your breathing find its rhythm, and your mind float through wonder. Before we begin, I'd love to know where you're listening from. Are you lying in bed under city lights, or watching the stars from somewhere quiet? Tell me in the comments. It's always peaceful to imagine the AstraFlow community scattered across the world, drifting together through the same sky. And if this calm journey brings you peace, you can gently support AstraFlow by liking this video or subscribing. It helps this little corner of the cosmos keep glowing. Now, let's begin tonight's voyage into the quiet mystery of extra dimensions. What does it truly mean to say that space has 3 dimensions? We repeat it so easily: length, width, height, as if those 3 directions are the entire vocabulary of existence. Yet the moment you sit with the idea, gently, quietly, with your thoughts unhurried, something begins to loosen around the edges. Why 3? Why not 2? Why not 10? Why should the universe limit itself to such a small set of directions, when its beauty elsewhere seems limitless? The question itself hums softly beneath the surface of physics. What if our senses tell an incomplete story of the world? We navigate space the way a fish navigates a pond, confidently, but only within the boundaries we can feel. Our eyes see forward, backward, left, right, up, and down, and our minds stop there, convinced these are the only ways reality can unfold. But human perception is not a perfect instrument. It evolved to notice fruit in trees and footsteps behind us, not to reveal the architecture of the cosmos. When you close your eyes and breathe slowly, you may feel how delicate that perception is. Your fingertips do not feel atoms. Your ears do not hear the pulse of space-time. Your thoughts do not stretch into invisible directions, at least not consciously. Yet physics suggests that beyond the familiar lattice of the world, there may exist wider corridors of motion, subtle angles of reality where matter, light, and time move differently. These possibilities arise not from fantasy, but from deep problems at the heart of science. Gravity behaves strangely, too weak compared to the other forces, too ghost-like in its reach. Quantum particles flicker and jitter with a language all their own. Einstein's smooth space-time cannot fully hold the wild dance of the microscopic world, no matter how gently we try to fit the pieces together. The puzzle resists completion unless one steps outside the room we are used to living in, and so physicists began to ask a radical question. What if the missing pieces are not missing at all? What if they simply lie in directions we never learn to see? As if the universe kept its deeper structure curled behind a curtain, not out of secrecy, but out of subtle geometry. This is the first threshold of our journey, the moment when we allow ourselves to consider that 3 is not a law, but a limitation, that our world could be a small, flat sheet embedded in something vaster. That reality might hold entire realms not because they are far away, but because they extend into directions our bodies were never built to detect. When you breathe in, imagine space expanding softly around you, not as a box, but as a horizon with hidden layers. When you breathe out, imagine those layers settling like waves, calm and patient, waiting to be understood. The first question of space is simple, but profound. Is the universe truly 3-dimensional, or is that only where our senses decide to stop? When scientists speak of extra dimensions, they are not imagining fantasy realms or magical portals. They are tracing the quiet edges of equations, patterns that whisper of something larger than the world we know. In the gentle stillness of late-night physics, a strange truth emerges. 3 dimensions are not enough to hold the universe comfortably. Something spills over. Something does not quite fit. And in that subtle misalignment, new possibilities begin to unfold. For more than a century, the greatest theories of nature have lived like neighbours separated by a thin wall. Einstein's smooth space-time on one side, calm, continuous, elegant. Quantum mechanics on the other, jittering, granular, unpredictable. Each beautiful, each precise, yet they refuse to fit together in a clean embrace. It's as if the universe were a great crystal shattered long ago, and we can hold only a few glittering fragments in our hands. Physicists began to ask, what if the fragments don't join because we're assembling them on a table too small? What if the puzzle can only be solved in a room with more directions, more dimensions than we can see? And so the map of reality expanded. In the soft logic of string theory, particles are not points but tiny vibrating loops. A string cannot hum freely in only 3 dimensions. Its music needs more space. Like a violin that cannot play inside a narrow box, the universe's deepest vibrations need room to resonate. Mathematics reveals the number, not 4, not 5, but 10 dimensions for strings. And 11 if membranes exist, great cosmic sheets stretching like silent waves. These numbers are not chosen. They arise the way a flower unfolds its petals, inevitably, elegantly. Yet if the universe has 10 or 11 dimensions, why do we see only 3? Physicists offer an image as gentle as it is profound. Extra dimensions may be curled up so tightly, so delicately folded that they hide inside every point of space like tiny secret chambers. Imagine rolling a sheet of paper into a straw. From far away, the straw looks like a simple line, one-dimensional. But with a closer glance, the hidden width returns. Space might behave the same way, wide and open in the large directions, but curled and tucked in the small ones, invisible to our eyes and instruments. These hidden dimensions could be all around you now, in the air you breathe, in the space between your hands, woven through the quiet darkness of your room as you rest. Not far away, not elsewhere, but here, everywhere, touching every point of our familiar world. And so, as the night deepens and your breathing slows, imagine that the space around you is more than it seems, a soft tapestry with folds you cannot see, a gentle fabric with hidden threads. The universe may be wider than our senses, deeper than our intuition, and more layered than we ever learned in school. This is the soft map of higher dimensions. Not a place, but a possibility. A quiet reminder that reality may be far larger, far subtler, and far more beautiful than the 3-dimensional room we drift through each day. To understand higher dimensions, we first return to the simplest idea. What is a dimension at all? Not complicated equation. Not a distant abstraction, just a direction you can move, forward and backward, left and right, up and down. 3 quiet freedoms braided together into the space you drift through every day. They feel so natural, so complete, that it's hard to imagine any other way for reality to exist. Yet the concept itself is beautifully gentle. A dimension is nothing more than a path, an option, a way for the universe to let you explore. When you picture a line, you see one dimension, a single thread stretching through space. Add another direction, and you have a surface, a 2-dimensional world like a page in a book. Add one more, and the world becomes spacious, a room you can walk through, a sky you can breathe beneath. Each dimension is a simple gift, another axis, another possibility, another quiet permission for movement. But dimensions are not limited to places we can go. They are part of how the universe organizes itself. If you lived on a sheet of paper, A true flatlander, you would know only front and back, left and right. You could draw a square, measure a circle, and map a city, but you would never conceive of height. To you, height would be myth, a rumour, an impossibility. It would be a direction that existed but refused to show itself. And yet, a three-dimensional being could stand just above that world, watching its cities, its citizens, its entire civilization, unseen, untouchable, but present. In the same way, our three-dimensional intuition is not the ceiling of reality. It is merely the plateau where our senses decided to stop. A dimension does not need our permission to exist. It does not depend on our eyes or our instruments. It is simply a possible degree of freedom in the fabric of space. A hallway the universe opens, whether or not we know how to walk through it. When physicists imagine extra dimensions, they are not conjuring fantasies. They are following a soft logic. If particles behave as if they have more room to move, perhaps they truly do. If forces refuse to align cleanly in 3 dimensions, perhaps they are shaped by directions we cannot perceive. If the equations hum with leftover structure, extra symmetries, extra angles, extra harmonies, perhaps the universe is quietly telling us, you are living in a space with more than you can see. So what is a dimension? It is a quiet possibility, a silent direction, a hidden freedom wrapped inside the geometry of the world. You do not feel these extra dimensions when you move your hands, or when you breathe, or when you turn your head on your pillow. But they could be there nonetheless, curled gently inside every point, woven into every moment, humming beneath every law of physics. As you rest tonight, imagine space not as a rigid box, but as a soft, unfolding fabric, full of paths you cannot yet walk and directions you cannot yet name. A dimension is simply one of those paths, and the universe may hold more of them than we ever imagined. To feel the possibility of higher dimensions, it helps to walk slowly through the ones we already know, not with equations or diagrams, but with imagery, gentle, simple, familiar, the kind that lets the mind drift without effort. Imagine first a point, a perfectly quiet place, no length, no width, no height, just existence, like a single note suspended in silence. A point cannot travel or turn, it has nowhere to go, it simply is. Now let that point begin to move. As it traces a path, it becomes a line, one dimension. Here, movement is possible, but only in 2 directions, forward or backward. A whole world could exist here, stretched like a tightrope, where beings know only the distinction between ahead and behind. To them the universe would feel complete, and yet to us it is thin, a thread drifting through the void. Then let that line sweep sideways and a plane opens, 2 dimensions, a sheet of reality, wide and flat, length and width, front and back, left and right, a world where creatures could build cities, draw maps, and trace the shapes of stars without ever knowing that above and below are even possible. A flatlander could spend a lifetime exploring that plane, unaware of the vastness hovering only a breath away. Now imagine lifting that sheet upward, and space blossoms, 3 dimensions, the room around you, the space where breath expands, where hands rise and fall, where clouds drift and disappear into the sky. Here, movement gains a new freedom, height, and suddenly the universe feels spacious, textured, alive. This gentle progression, point to line, line to plane, plane to space, is not just geometry. It is the story of possibility expanding, of the universe revealing itself, one hidden direction at a time. And then comes the quiet realization. If the leap from 2D to 3D opens an entire universe, then what might the leap from 3D to 4D or 10D reveal? For a 2-dimensional being, the 3rd dimension would be unimaginable. Not because it is complicated, but because it lies outside their experience. A flatlander cannot picture height. Their senses do not reach in that direction. To them, our world, with its breathing creatures and rising oceans and drifting clouds, would seem magical, impossible, mythic. And yet, here we are, living comfortably in it. So when physicists propose higher dimensions, they are not claiming the universe is strange. They are pointing out that we may simply be flatlanders of a different kind, creatures adapted to a three-dimensional pond, swimming through a small piece of a much wider ocean. As you lie here tonight, consider how natural three dimensions feel, how effortlessly your mind locates objects in space, how familiar every direction seems. And then imagine that this sense of completeness is just a local truth, a useful truth, but not the whole truth. If a point can become a line, and a line can become a plane, and a plane can become a room, then perhaps a room can become something more as well, something we cannot yet visualize, something that awaits us beyond the edges of imagination, quiet, hidden, patient. The journey from point to space is a reminder that the universe has always had more to show us than we first believed. For all our confidence in the world, our perception is astonishingly narrow. We move through space as if we understand it, as if the room around us is complete, tidy, fully revealed. Yet our senses give us only a sliver of reality, a thin slice cut from a far larger whole. Like a window left slightly open, they let in just enough truth for us to survive, but not nearly enough to understand the universe's deeper architecture. Think of the senses we rely on every moment. Your eyes respond to less than 1% of the electromagnetic spectrum, a tiny island of colour floating in an infinite sea of unseen wavelengths. Your ears detect only a narrow band of sound, ignoring vibrations below and above the modest limits evolution set for us. Even your sense of touch, so intimate and immediate, perceives nothing of atoms or fields, or the soft curvature of space-time beneath your fingertips. We live inside a filter, a beautiful one, but a filter nonetheless. If a creature evolved with broader senses, eyes tuned to gravity, ears attuned to quantum fluctuations, skin sensitive to the folding of dimensions, it would find our three-dimensional world strangely incomplete. It would notice angles we cannot see, pathways we cannot follow, subtle flows of energy that slip silently past us. What feels to us like the full story of existence might appear to that creature as nothing more than a dim sketch. Yet we rarely question our limitations. Our minds stitch together the fragments our senses give us and say, "This is the world." But the world is not bound to our perception. It stretches gently beyond sight and sound, beyond intuition, beyond everything that feels familiar. When physicists consider higher dimensions, they are not abandoning reason. They are acknowledging that our sensory map of the world is incomplete. If a flatlander cannot perceive the third dimension, why assume we can perceive all of them? If a koi fish in a pond cannot imagine the world above the water, why should we assume there is nothing above our own conceptual surface? The thinness of perception is not a flaw. It is a reminder of humility, a gentle hint that the universe does not reveal all its layers at once. It offers what we need to navigate our everyday lives, the swing of a door, the weight of gravity, the distance to the moon. But it keeps its deeper structure tucked away, folded neatly behind veils we are only beginning to understand. As you rest tonight, feel the softness of this truth. Your senses do not fail you. They simply tell a local story, the story of a creature adapted to one environment on one small planet. There is no reason to expect them to uncover the universe's hidden dimensions any more than a compass can reveal the taste of sunlight. Let your breathing slow, like waves settling on a quiet shore. Let each exhale remind you of the limits we all share, and let each inhale invite the possibility that reality is larger, richer, and more mysterious than our bodies were built to perceive. In that thin gap between what we sense and what truly is, higher dimensions may be waiting, silent, patient, everywhere. Imagine a quiet pond at sunset, still, silvered, barely trembling beneath the fading light. Beneath its surface, small fish drift in gentle patterns, weaving left and right, forward and back, tracing soft movements across a two-dimensional sheet. To them, this thin world is everything. It holds their entire horizon, their entire history, the entire map of what they can know. They do not sense the sky above, or the trees reflecting in the water, or the hand of a child leaning over the edge. Their universe is a pond without height, a world with only two directions to explore. Michio Kaku often spoke of these koi fish, gliding peacefully through their 2D realm. Their eyes sit on the sides of their heads. They do not see up. They cannot imagine that up is even a direction. The world above is silent to them, invisible, unreachable, and unimaginable. And yet the world above exists fully, vibrantly, overwhelmingly. The fish simply have no way to detect it. Now imagine gently that one fish, perhaps a curious one, swims close to the surface, brushing the boundary of its entire universe. It feels nothing unusual, just a thin membrane, consistent with everything it has ever known. But on the other side of that membrane lies an entire dimension it cannot perceive. Birdsong, breeze, stars, life layered beyond its comprehension. We humans are not so different. We glide through our three-dimensional pond with confidence, forward and backward, left and right, up and down. To us, these directions feel complete. They fit our bodies, our intuition, our memories. We do not sense the dimensions stacked beyond them, the higher corridors that physics suggests may exist just outside the boundaries of our perception. If the pond dweller could speak, it would insist. There is no world above, there is no up. Not out of ignorance, but because its physiology offers no way to experience that truth. If we could lift the fish gently from the pond, just for a moment, the creature would witness impossible things. Beings that breathe without water, creatures moving without fins, a realm where its rules no longer apply. And when placed back into its pond, it would struggle to explain what it saw. Its words would fall short, its metaphors would falter, and its memories would sound like fiction. Physics suggests we may be living inside the same kind of limitation. We assume 3 dimensions because our bodies evolved to navigate 3. But evolution has never been a cartographer of the cosmos. It does not design senses to detect higher realms. It designs senses to survive. As you breathe slowly, imagine that we too are koi, drifting within a serene pond, unaware of the vastness above us. Imagine that the surface of our universe is not a boundary of existence, but simply the edge of what our senses can know. Imagine that beyond this surface, hidden in silence, lies a space richer than our imagination, a space that touches every moment, every atom, yet never reveals itself directly. We are creatures of a dimensional pond, comforted by the familiar, unaware of what surrounds us. And like the koi, we may one day discover that the world we took as complete was only a small part of something deeper, wider, and wonderfully beyond our sight. Imagine for a moment that you could reach gently into that quiet pond, the 2-dimensional world of the koi, and lift one curious fish into the air. Not with force, not with fear, but with the soft care of someone revealing a truth too large for words. In an instant, the fish would cross a boundary it never knew existed. It would leave behind its thin, flat universe and rise into a realm filled with strange new laws. What would that fish see? At first, perhaps nothing but confusion. Its senses were built for a 2D sheet, not the spacious flow of a 3D world. The shimmering surface it once took as the edge of all existence now becomes a boundary it looks down upon, a direction it never believed was real. Suddenly the pond is no longer a universe, but a small, shimmering circle floating far below, and everything it thought was impossible now surrounds it effortlessly. Beings breathing without water, creatures moving without fins, forces acting without ripples, a vastness unfolding in every direction. In the transcript, Michio Kaku describes this moment vividly. The fish would witness an entirely new biology, an entirely new physics, all within seconds. To the fish, these revelations would feel miraculous, even frightening. Not because they break the rules, but because they reveal that the rules were never as fixed as it believed. And then comes the most profound part. You gently return the fish to its pond. The surface closes above it. The light dims, the familiar currents return. But the fish has seen too much to forget. It swims through its world with new eyes. Eyes that have witnessed a dimension beyond its nature. How would it describe what happened? Maybe it tries to explain up, but the word has no meaning. Maybe it speaks of creatures shaped unlike anything in its plane, but no one believes it. Maybe, like many thinkers throughout human history, it struggles to articulate a truth that language was never designed to hold. And yet, it remembers. Physics suggests that we may be that fish, lifted only briefly by mathematics, by imagination, by the quiet logic of nature's hidden structure. Higher dimensions may be just as real, just as present, just as all-embracing as the world above the pond. We simply lack the senses to perceive them fully. Our minds evolved to navigate 3 directions. Our eyes evolved to see only a thin slice of the electromagnetic spectrum. Our intuition evolved for survival, not for cosmic understanding. But every so often, through equations, through thought experiments, through the soft curiosity you feel right now, we rise just a little. We glimpse the possibility of a world wider than our senses. We sense the shape of something larger, even if we cannot touch it. And when we return to our everyday lives, to rooms, to streets, to the ordinary choreography of our days, a small part of us carries that memory, a feeling that space might not end where we think it ends, that reality may have more directions than the ones we walk through, that existence itself may be deeper, richer, and more layered than the human mind was ever taught to imagine. We too may have been lifted, just for a moment, into the 3rd dimension of a larger truth. When you imagine the koi lifted from its pond, seeing a world it never knew existed, the metaphor is soft, almost whimsical. But the deeper question it carries settles quietly into the mind. What if we are the fish? What if our familiar 3-dimensional universe is just a thin sheet, floating within a larger unseen reality? What if we too swim confidently in a limited world, unaware of the vastness above and below us? Humans rarely consider this possibility, because our senses feel complete. We wake, walk, breathe, turn, stretch, and occupy space without hesitation. Every direction we know feels present, functional, enough. But the koi feels the same way in its 2-dimensional pond. To that fish there is no sense of something missing, no hint of a forbidden direction, no intuition of a sky. Its world feels complete until it isn't. Physics invites us to contemplate that same boundary in our own lives. We move through length, width, and height, as if they are the entire vocabulary of reality. But if a 4th spatial direction exists, or 5, or 6, we would never feel them. They would be invisible, inaudible, intangible, not because they are distant, but because our bodies cannot register them, just as the koi's body cannot register up. People often assume that if something exists we should be able to sense it, but our sensory world is astonishingly limited. We see less than 1% of light, hear a small fraction of sound, and feel only the bluntest vibrations of matter. Why should dimensions be any different? Why assume our bodies evolved to perceive the universe's full structure, rather than just enough to survive. Imagine, for a moment, that a four-dimensional being is watching you now, not with judgment or mystery, but with the same calm curiosity that a child shows while looking into a pond. It would see your 3D world spread out like a thin membrane. It would see you moving through your daily motions, unaware of its presence. Not because you are small or simple, but because your senses are tuned to a different layer of reality. To that being, up and down would be only part of the story. It might move in directions you cannot imagine, sideways into the fourth dimension, or drifting through angles impossible to describe with human language. You would never notice its motion. You would never see the ripple it makes through space, just as the koi never sees your shadow on the water. And yet, you coexist. This idea is not meant to unsettle, but to soften, to remind you that mystery is not distance. Mystery is simply a feature of limited perception. In the same way a fish cannot imagine the world above the pond, you may not be able to imagine the worlds nested around you. But they could still be there, woven silently into the fabric of existence. As you breathe slowly tonight, let yourself drift into this possibility. Feel the calm of knowing that your understanding is just one layer among many. Feel the wonder of recognizing that reality might be far larger than the space you inhabit. Feel the peace of accepting that not seeing something does not make it any less real. If we are the fish, then perhaps the universe is gently waiting for the moment we notice the surface above our own pond. To explore higher dimensions, we often begin with one that feels familiar yet elusive: time. Though we move through it as naturally as through space, time is different, gentler, more mysterious, always slipping away even as we reach for it. And still, it acts as a kind of bridge, a hint that reality has more structure than our senses perceive. If space gives us 3 dimensions to roam, time gives us a silent fourth, carrying us forward in a direction we cannot reverse. You can walk across a room, turn around, and retrace your steps. You can reach upward toward the ceiling, or downward to pick up something you dropped. But you cannot move backward in time. You cannot pause it, or step aside from it, or take a shortcut through it. You drift along its current the way a leaf floats on a river, gently carried from moment to moment. This one-way flow is so constant, so absolute, that it often feels more like a law of nature than a dimension. Yet in Einstein's vision of the universe, time fits seamlessly beside length, width, and height. It is stitched into the same fabric, woven into the same geometry. A moment is not separate from a place. The two form a single entity called space-time, a vast tapestry in which every event has both position and time. You're not just somewhere, you're also somewhen. Every breath you take has coordinates along this fourth axis. Einstein showed that time bends and stretches alongside space. Gravity slows it down, motion dilates it. The closer you move to the speed of light, the more time loosens its grip. In some cosmic regions, near black holes or within dense gravitational fields, time itself trembles, thickens, or nearly stops. It is not rigid, it is not mechanical, it is supple, flexible, alive. This flexibility is the first hint that time may be more than a simple flow. It behaves like a dimension, a direction that intertwines with others, a path governed by geometry. And so we begin to glimpse a deeper truth. If time can bend, perhaps other hidden dimensions can bend as well. Imagine floating above your own timeline, rising gently out of the steady current of moments. From this viewpoint, you might see your life not as a sequence, but as a whole. Childhood, present, future, all laid out like a shimmering trail across space-time. To a being who can move freely through this fourth dimension, your entire journey would be visible at once, like a constellation drawn across the sky. We cannot take this perspective ourselves, not with our bodies, not with our senses. but mathematics allows us to hint at it, the way the edge of a shadow hints at the shape of a hidden object. Time invites us to imagine dimensions not yet revealed. It proves that reality is not confined to the three directions we navigate daily. It reminds us that dimensions can behave differently, unfold differently, whisper different truths about existence. As you lie here tonight, breathing slowly, let yourself feel the gentle flow of time, each moment arriving like a wave, touching your awareness and receding softly into memory. Notice how you cannot hold it, cannot turn it, cannot escape its current, and yet, in its stillness, it shows you something profound. You are already drifting through a dimension beyond space. You are already part of a four-dimensional world, and beyond that world there may be others, quiet, hidden, waiting for us to notice. When you imagine space, you might picture something empty, a quiet stage on which the universe performs. But Einstein revealed something far softer and more intricate. Space is not a backdrop, it is a fabric, a living, flexible surface that bends, stretches, and flows with whatever it carries. In this view, gravity is not a pull but a curve, not a force that tugs, but a gentle dip in the geometry of space-time itself. Picture a smooth cloth held taut in the air. Place a single marble on it, and the cloth dips softly beneath the weight. Place a larger sphere, and the dip deepens, shaping the motion of anything nearby. This is gravity, not an invisible hand pulling downward, but the natural motion of objects following the curves in space-time's fabric. The Earth orbits the Sun not because it is yanked around, but because the Sun bends space-time into a quiet valley, and Earth simply rolls along that valley's path. This idea, simple yet profound, transforms the universe into a continuous responsive landscape. Stars flare, galaxies spin, planets drift through orbits carved by invisible curves. Even the light you see from distant galaxies bends subtly around massive objects, tracing arcs that reveal the shape of the cosmic fabric. This living geometry is our first true glimpse of higher dimensional thinking. In Einstein's equations, time is stitched seamlessly into space. Together they form a four-dimensional cloth, smooth and elegant. And in that cloth curves are everything: the arc of a falling apple, the orbit of the moon, the path of a beam of starlight. But something unexpected happens when physicists try to combine this graceful picture with the jittering chaos of the quantum world. Einstein's fabric is smooth. Quantum fields are grainy, restless, unpredictable. One describes vast galaxies, the other describes subatomic particles. They do not fit naturally together, not in 3 dimensions, not in 4. It is here that the idea of extra dimensions begins to glow. If space-time is a fabric, perhaps it is woven from more threads than we realized. Perhaps its curves extend not only in the directions we see, but into hidden corridors our senses cannot touch. Perhaps the reason gravity is so gentle, so much weaker than the other forces, is that it spreads out through these unseen dimensions, diffusing its strength across a broader landscape. Einstein's curved fabric hints at this quietly. It tells us that space is not rigid, not solid, not limited. It is a surface capable of bending in ways we cannot directly perceive, just as a koi fish in a pond might sense ripples without understanding the air above the water. As you listen tonight, imagine that fabric gently supporting you, soft, expansive, humming with silent motion. Imagine the bed beneath you resting on a world that curves imperceptibly, its geometry shifting with every passing star. Imagine that this fabric does not end with the dimensions you know, but folds into others that drift just beyond your awareness. Einstein gave us the first glimpse of this possibility, the first realization that space is not a passive emptiness, but a dynamic form capable of far more than we once believed. And in those quiet curves, the story of higher dimensions begins to unfold. For more than a century, physics has been guided by two masterpieces, quantum mechanics and general relativity, each elegant, each powerful, each describing a different realm of reality with breathtaking accuracy. And yet, when we try to bring them together, they resist like mismatched puzzle pieces, beautiful on their own, but incompatible when pressed side by side. Quantum mechanics governs the smallest scales, atoms, particles, the restless hum beneath all things. It is a world of probabilities, of waves that become particles only when observed, of energy flickering in and out of existence like tiny sparks. Its mathematics is sharp, precise, and strange, a language that reveals nature's microscopic heartbeat. General relativity, by contrast, governs the grand. Planets, stars, galaxies, the vast curvature of space-time itself. Its equations flow like poetry, describing gravity as geometry, motion as the natural response to the bending of the cosmic fabric. Both theories have been tested, both have been confirmed, both have shaped our understanding of the universe, and yet, when they meet, in black holes, in the earliest moment of the Big Bang, in the deepest cores of space-time, they clash. The smooth fabric of Einstein tears under the jittering pressure of quantum fields. The sharp mathematics of quantum theory dissolves inside the curved depths demanded by relativity. It is as if the universe speaks two dialects that cannot be combined without losing meaning. Physicists struggled for decades, trying to merge the pieces into a single unified picture. But the more they tried, the clearer the problem became. The three-dimensional world we inhabit is too small for both theories to fit inside at once. And so, a new idea began to emerge, quietly at first, then with growing clarity. What if the mismatch is not a flaw in the theories, but a flaw in our assumptions? What if the puzzle refuses to fit because we are assembling it in the wrong number of dimensions? This is where the metaphor of the shattered crystal becomes powerful. In the transcript, Michio Kaku describes the early universe as a perfect crystal, a unified theory that shattered into pieces during the Big Bang. Each fragment became one of the forces we now know: gravity, electromagnetism, the nuclear forces. To us, these pieces look disconnected, like shards scattered across a tabletop. But a higher dimensional being might see the full crystal instantly, fitting the pieces together with ease. In our three-dimensional world, the fragments appear separate. In a higher dimensional space, they become one. That is the essence of modern theoretical physics. Relativity and quantum mechanics are not incompatible. They are simply incomplete, parts of a larger whole, hints of a deeper geometry, clues pointing toward hidden directions where their contradictions dissolve into harmony. As you rest tonight, imagine those two theories not as rivals, but as melodies waiting to be combined. Imagine the universe as a symphony too wide for our limited stage, its full harmony audible only when played across more dimensions than we can see. Imagine that the discord we hear is not the universe's flaw, but our own limited vantage point. Sometimes when pieces refuse to fit, it is not because they are wrong, but because the puzzle is larger than we realized. Imagine holding a perfect crystal in your hands, clear, unified, flawless. Every facet reflects the others. Every surface fits naturally into the whole. Nothing is separate. Nothing is broken. This is how physicists imagine the universe at the very beginning. A single, harmonious force, a unified structure before anything had time to fall apart. But perfection is fragile. The moment the universe expanded, in that first breath of the Big Bang, the crystal shattered. Not violently, but inevitably, like glass warming too quickly under a sudden flame. Its pieces scattered into patterns we now experience as the laws of nature. Gravity drifting one way, electromagnetism another, the nuclear forces unfolding into their own intricate forms. Michio Kaku describes this vision beautifully, a cosmic crystal breaking into fragments we mistake for unrelated truths. To us, each piece appears unique. Gravity feels weak and ghost-like. The electromagnetic force feels strong and immediate. Quantum fields dance unpredictably. Relativity curves space-time with serene precision. Each fragment seems to follow its own rules, its own rhythm. But imagine, for a moment, that all these pieces were once connected. Imagine that the scattered laws of physics are simply shards of a deeper whole we no longer remember. From within our three-dimensional world, we see only fragments on a tabletop, scattered with no obvious pattern. But from a higher dimensional perspective, the pieces might slide perfectly into place, edges aligning, facets locking into harmony, revealing the crystal's original shape. This is the heart of higher dimensional thinking. The puzzle appears broken only because we're assembling it in too small a space. If you try to reconstruct a shattered sculpture on a flat surface, some pieces will never fit without lifting them into the air. The missing dimension prevents the restoration, but the moment you add height, the moment you move into the third dimension, the sculpture rises again, whole and beautiful. Physics suggests something similar. The universe's broken pieces do not fit inside 3 dimensions, but they might fit seamlessly within 10 or 11. This idea is not just poetic, it is the guiding intuition of string theory. A unified force can exist cleanly only in higher dimensions. All the fragments of nature's laws fit together, but only when allowed to move in directions we cannot see. Just as the koi fish cannot understand the shape of the world above its pond, we cannot perceive the structure of the higher dimensional crystal. Yet signs of its existence echo through our world. The strange weakness of gravity, the shimmering symmetries of quantum fields, the tension between the large and the small. These are cracks running through the fragments, reminders that the pieces were once united. As you rest tonight, allow yourself to imagine the universe as something whole rather than fractured, not a chaos of separate forces, but a single crystal shattered by cosmic birth, its fragments still shining through every atom, every star, every breath you take. The unity is still there, hidden, curled within higher dimensions, waiting to be seen again. One day, our understanding may rise into that higher space, but for now we drift among the shards, tracing their shapes, learning their stories, sensing the perfection that once was. If all the forces of nature were once part of a single, perfect whole, then every scientific question becomes a search for the lost crystal, the original unity hidden beneath the fractures of the universe. And quietly, almost reluctantly, physics has revealed a remarkable truth. The fragments refuse to merge in 3 dimensions, no matter how gently we try to fit them together. The table is too small, the space too cramped. The pieces lock only when lifted, when given room to move in directions we cannot see. Gravity sits alone in its softness. Electromagnetism hums brightly through every atom. The strong and weak nuclear forces cling fiercely to the heart of matter. 4 distinct facets, each essential, each powerful, each describing a different kind of motion or interaction. In our everyday world, they feel unrelated, like separate stories told by separate narrators. But if you listen closely, beneath the surface of these forces lies a deeper rhythm, faint but insistent, suggesting they are siblings, not strangers. Physicists have long tried to bring them together, to reconstruct the original harmony. But every attempt in the familiar 3 dimensions ends in contradiction. The equations clash, constants refuse to match, curves collide with probabilities. It is as if we have all the right fragments but are working on the wrong surface, trying to rebuild a sculpture on a table when it was meant to stand tall in open space. In higher dimensions, something miraculous happens. The jagged edges of one equation align with the curves of another. The scattered symmetries begin to lock into place. Gravity, electromagnetism, and the nuclear forces flow into one another through unseen corridors. What feels broken in our world becomes smooth in a larger one, as if the crystal remembers itself in those hidden dimensions. String theory, and later M theory, uncovered this possibility not through speculation but through necessity. Particles behave like vibrating loops, and loops require space, more space than 3 dimensions can provide. Extra dimensions allow the vibrations to harmonize, giving each force its unique frequency, while still fitting them into a single framework. It is like discovering that the puzzle pieces were never damaged. They simply needed to be lifted off the table and placed into the 3rd dimension of insight. When we imagine the universe this way, the brokenness begins to soften. The forces of nature become not rivals, but reflections, shards of a whole that shattered during the Big Bang. The higher dimensional crystal is still there, folded quietly into the geometry of reality, influencing every movement of stars and particles even if we cannot fully perceive it. As you breathe slowly tonight, imagine the unseen structure that holds everything together. Imagine each force as a glimmering facet of a larger jewel, one that shines most clearly only when viewed from a dimension beyond ours. Imagine that every law of nature, from the fall of an apple to the birth of a galaxy, is the echo of this hidden unity. We may not yet know how to enter those higher dimensions. We may not be able to lift the crystal fully into view. But with each new insight, each experiment, each equation, we brush our fingers against the edges of something deeper, a reminder that the universe was once whole, and that its wholeness still waits, folded gently into the spaces beyond our sight. In the quiet heart of modern physics, a simple truth echoes again and again. Our universe feels incomplete in 3 dimensions, not emotionally, not philosophically, but mathematically, the deepest language nature speaks. In that language, the equations that describe our world stretch, strain, and break, unless they are allowed to flow into hidden directions. As if the universe were whispering, "You're trying to understand a 4-dimensional story with only 3 pages." When scientists study the forces of nature, they find patterns that almost fit together, symmetries that almost align, equations that almost merge. The almost is haunting. It is like standing before a doorway that nearly closes but leaves a sliver of light shining through the edges. That sliver hints at something bigger, a shape just out of view. String theory enters here with a quiet inevitability, not as a wild guess, but as a consequence of mathematical consistency. If particles are tiny vibrating strings rather than points, those strings need room to move. But 3-dimensional space is not roomy enough. The vibrations collapse, the mathematics breaks, the symmetries fail to form. Give the strings more dimensions, 10 specifically, and suddenly the symmetries bloom, the equations smooth, the harmonies appear. Everything that refused to fit in 3 dimensions falls gently into place, like puzzle pieces sliding into their natural positions. It is startling and beautiful that mathematics itself demands more dimensions. They are not added for flair or fantasy. They arise because the universe will not balance without them. And so physics leans toward the extraordinary, a world where the space you move through is only a small part of the full geometry of existence. A world where the forces we experience, gravity, electromagnetism, the strong and weak nuclear forces, are reflections of deeper motions in higher dimensional space. A world where the laws of physics are not separate laws at all, but the shadows of a single elegant principle unfolding beyond our sight. The idea is often unsettling at first. How could we live inside a multi-dimensional universe and not know it? But the koi fish in the pond does not sense the sky. The flatlander does not feel height. Their worlds feel complete, even though they are thin. Ours might be thin as well, a narrow slice of something much more expansive. As you lie here, breathing slowly, imagine that the space around you has hidden depth. Not metaphorically, but literally. Folded directions intertwined within every point. Dimensions you cannot sense because your body was never built to move in them. Dimensions that keep the equations of the universe balanced, graceful, unbroken. Physics needs more dimensions because the universe seems to be written that way, not in 3 chapters, but in many. And though we can read only the surface story, the deeper tale is still there, humming beneath everything we see, the harmonies of space, the curves of time, and the secret directions that hold them together. Every science student grows up believing that mathematics is a tool, sharp, precise, obedient. But in the deeper layers of theoretical physics, mathematics behaves less like a tool and more like a guide. It leads, it hints, it refuses to bend when the universe demands truth. And in the quiet study of higher dimensions, mathematics has revealed something astonishing. Only certain numbers of dimensions allow reality to remain stable. When physicists followed the logic of string theory, they didn't choose 10 dimensions because it sounded mystical. They discovered 10 because the equations broke everywhere else. Like a bridge that collapses if even one support beam is misplaced, the universe's symmetries fell apart when the number of dimensions was anything but 10. 10 is not decorative, it is structural. In 10 dimensions, vibrating strings behave perfectly. They hum with precise harmonies. Their mathematical description becomes smooth, self-consistent, impossibly elegant. Remove a dimension, and the harmonies distort. Add one too many, and the structure collapses. It is as though the universe prefers 10, not as an option, but as a necessity. And then came the quiet revolution. M-theory. Physicists realized that string theory's 5 competing versions were actually shadows cast by a deeper, 11-dimensional truth. Add one more dimension, just one, and the fragments merge. Strings become membranes, loops expand into sheets, particles unfold into surfaces, bubbles, and cosmic drifts beyond the imagination. The entire structure gains a gentle coherence, as if the universe has been waiting for us to notice that its true geometry requires 11 dimensions, not 10. Michio Kaku and others pointed out something extraordinary. Not every number of dimensions can support a stable universe. 13 dimensions collapse, 15 unravel, 29 are mathematically chaotic, but 11 holds, 11 supports membranes. 11 allows gravity to stretch across multiple layers of reality. 11 is the upper limit where the equations of existence remain balanced, quiet, complete. It is humbling to realize that the universe is not arbitrary. It chooses its structure with the same care a musician chooses intervals in a chord. Too narrow, and the harmony suffocates. Too wide, and the melody dissolves. But in just the right number of dimensions, the symphony holds, and yet we perceive only 3. Not because the others are absent, but because they may be compatified, curled so tightly inside the geometry of space that your body cannot move through them, your senses cannot detect them, your intuition cannot grasp them. They hide inside every point of reality the way tiny spirals hide inside a seashell. The shell may look smooth from a distance, but its true beauty lies in the intricate curls folded within. As you rest tonight, imagine the space around you not as simple emptiness, but as something exquisitely layered. 3 dimensions wide, 1 dimension flowing, and 6 or 7 more curled softly into the fabric of existence, unseen, silent, but essential. The magic numbers 10, 11 are not coincidence. They are the signature of a universe far richer than our senses can reveal. A universe whose true structure is written not in what we can see, but in the dimensions we cannot. Imagine the universe not as a collection of particles, but as a vast orchestra. Every atom, every force, every moment arising from vibration. Not the vibration of air or stringed instruments, but the vibration of something far smaller, far more fundamental. Tiny filaments of energy. Loops so delicate they dance at the very foundation of existence. These are the strings of string theory, the building blocks of reality, humming softly through dimensions we cannot see. In this picture, particles are not solid beads or points. They are notes. Their properties, mass, charge, spin, are simply the tone each string plays as it vibrates. Change the vibration, and you change the particle. A photon is a string plucked one way, an electron plucked another. Everything we observe becomes part of a cosmic symphony, woven from patterns too small for any microscope to reveal. But there's a secret hidden inside this music. Strings cannot vibrate freely in a space with only 3 dimensions. The melodies break, the equations collapse, the structure falls apart. It is as if the universe built its deepest instruments to play in a grand hall, only for us to insist on squeezing them into a narrow corridor. To vibrate properly, to create the forces and particles we know, strings need more room. Not more space as we understand it, but more dimensions. 6 additional ones curled so tightly that we cannot step into them or move through them. Invisible to our senses, but essential to the string's ability to sing. These hidden dimensions act like resonating chambers in a musical instrument. A guitar string without its wooden body would be thin and weak, almost silent. It is the hollow interior of the guitar, the space you never directly see, that enriches the sound. Similarly, the curled-up dimensions of string theory give structure and richness to the vibrations of reality itself. Michio Kaku hints at this when he describes our world as just a brain, a 3-dimensional membrane floating through a larger ocean of space. In that ocean, strings vibrate not only across the dimensions we know, but through corridors folded invisibly into every point around you. These curled directions shape the universe quietly, their influence rippling outward into the familiar world. In your room right now, higher dimensions may be woven into the air, drifting in the silence between breaths. Not metaphorically, literally. Every particle you feel, every beam of light that touches your eyes, every atom in your body contains pathways that curve into unseen directions, coiling back upon themselves like tiny labyrinths hidden inside reality. You cannot walk into those dimensions. You cannot reach into them with your hands, but the strings can. They vibrate through every direction available to them, whether or not you know those directions exist, and the harmony that results, the harmony of vibration across 10 dimensions, becomes the physics of the universe you experience every day. As you breathe slowly, imagine yourself lying gently on a membrane of space. Imagine that beneath you, inside you, and all around you, strings are humming, weaving a soundless music that holds reality together. Imagine that each vibration is shaped by hidden dimensions, curled softly like petals around the core of existence. You may never see these dimensions, you may never touch them, but every part of your world, every star, every cloud, every heartbeat is built from the vibrations they allow. Reality itself is made of music, and the universe is its silent instrument. To imagine higher dimensions, it helps to picture something simple, a sheet of paper rolled into a tight tube. From far away, the tube looks like a line, thin and straight, a one-dimensional strand. But move closer, and you see that the line has hidden depth. Walk along its length and you travel through one direction. Circle around its curve and you travel through another. 2 dimensions, quietly disguised as one. This is the essence of compactification, the idea that extra dimensions can be real, present, and woven into space itself, yet remain hidden because they are curled too tightly for any creature or any particle to enter. Michio Kaku describes it beautifully. Just as smoke cannot drift into a fourth spatial direction, and atoms cannot leak into hyperspace, the extra dimensions must be smaller than any particle we know. They are curled so finely, so delicately that their openings are too narrow for matter to slip through. These dimensions are everywhere, but unreachable. Imagine the room around you now, the air, the gentle shadows, the quiet surfaces. Within every inch of that space, within every point, every atom, every breath, there may be 6 or 7 curled directions, wound into spirals smaller than anything your senses can detect. Not elsewhere, not far away, but right here, touching every moment of your reality. If your eyes could shrink smaller than an atom, and smaller still, you might eventually find a hidden tunnel, a looped dimension folded upon itself like a microscopic labyrinth. It would not stretch outward the way length or height does. It would fold inward, like the intricate spirals of a seashell or the coils of a tiny spring. These hidden dimensions shape physics not by allowing us to walk through them, but by guiding how strings vibrate inside them. Their shapes determine the harmonies of matter. Just as the body of a violin shapes the resonance of its strings, the curled-up geometry of the universe shapes the vibrations of particles. Change the shape of the extra dimensions and the entire melody of reality, the masses of particles, the charges, the interactions, would shift. Some physicists describe these curled spaces as Calabi-Yau manifolds, delicate multi-dimensional structures that look like impossible origami folded into the smallest crevices of existence. Others see them as tiny loops, like threads woven into every point of space. However you picture them, the essence remains the same. Higher dimensions are not far, they are close, closer than your own breath. But their smallness hides them completely. No human instrument can probe such tiny scales. Not yet. We live on the large, flat surface of reality, while the true depth of the universe curls inward beyond sight. As you breathe gently, imagine holding a sheet of space in your hands. Imagine rolling it softly into a tube, then tighter still, until the direction you once walked freely becomes so small it vanishes from sight. But it does not vanish from existence. It remains curled inside the structure, influencing everything quietly from within. Compactified dimensions may be invisible, but they are not irrelevant. They are the hidden architecture that allows particles to exist, forces to flow, and the universe to hum with order rather than chaos. We may not see these dimensions, but every part of reality, including you, is shaped by their silent spirals. The idea of hidden dimensions can feel abstract, distant, theoretical, almost unreal. We imagine them as faraway realms tucked behind cosmic curtains or sealed inside unreachable domains. But the truth suggested by modern physics is far more intimate. The extra dimensions, if they exist, are not somewhere else. They are here, interwoven with every sip of air, every particle of light, every heartbeat echoing gently in your chest. Michio Kaku often emphasizes this point. If higher dimensions exist, they touch our world at every point. Not occasionally, not rarely, at every point. Just as the surface of a pond touches the surrounding space at every ripple, so too does our three-dimensional universe touch the larger hyperspace that contains it. Imagine standing in the center of your room, quiet and still. To your eyes, the space around you appears continuous and empty, a simple volume bounded by walls. But physics suggests a richer picture within each point of that space. 6 or 7 curled dimensions may be folded into microscopic spirals, too small to see, too tight to move through, yet always present. You are surrounded by them. You're immersed in them. In a sense, you're made from them. Every atom in your body carries strings vibrating through these hidden directions, their melodies shaped by the geometry of dimensions too tiny to imagine. Every beam of starlight that enters your eyes weaves softly through a fabric containing more than 3 directions. Every gravitational ripple drifting across the cosmos may slip gently through these extra dimensions, its path influenced by spaces we never learn to perceive. The invisibility of these dimensions does not make them distant. It makes them subtle. Just as wind carries scents you cannot see, or air vibrates with sounds beyond your hearing, the universe may carry hidden structure beyond the reach of your senses. Sitting still, you are closer to these dimensions than you are to the nearest star, closer than you are to the nearest cloud, closer even than you are to the floor beneath your feet. Because these dimensions are not above or below, they are inside the very points of space you rest within. Think of a sheet of paper. From a distance, it looks flat. Move closer, and its texture reveals tiny hills and valleys. Closer still, and you may see fibers curled around one another, forming a labyrinth of hidden shapes. Each scale reveals new structure. Space may behave the same way. From your everyday perspective, it is smooth, but deep within each point lies complexity folded into invisibly small spaces, extra dimensions hidden as tightly as threads in fabric. As you breathe slowly, imagine that each inhale draws in air woven with unseen pathways, and each exhale drifts through subtle corridors your senses cannot track. Feel the quiet possibility that space is not empty but layered, not limited but profound, not confined to 3 directions, but enriched by hidden ones surrounding you even now. The universe does not place higher dimensions beyond your reach. It places them everywhere, tucked softly into the architecture of reality, waiting for the moment we learn how to see their influence. You don't need to travel far to find them. You're already inside their embrace. If higher dimensions truly surround us, curled into every point, hidden in every breath, then a natural question arises. Why can't we move through them? Why can't we slip into those unseen directions the way we step forward or reach upward? Why are they present, yet inaccessible? The answer lies not in distance, but in scale. Physics suggests that these dimensions are wound so tightly into the fabric of reality that no particle we know can fit through their openings. They are smaller than atoms, smaller than quarks, smaller than anything we have ever measured, so small that to us they appear sealed shut. Michio Kaku uses a simple, elegant image to describe this. Smoke drifting through a room. Smoke can fill the air, spread into every corner, push through tiny cracks. But no matter how it flows, it never leaks into a 4th spatial direction. Not because that direction is absent, but because it is too small for the smoke to enter. The same is true for atoms. If higher dimensions were large, matter would disperse into them, vanishing like mist into another realm. Gravity, electromagnetism, the very stability of your body, all would unravel, but they don't. Atoms remain whole, matter stays intact. Which means the extra dimensions, if they exist, must be curled so tightly that nothing we know can slip through. You can imagine these compact dimensions like tiny tunnels spiraling inward on themselves, loops so narrow that even the smallest particle cannot enter, like trying to push a marble through the eye of a needle, a trillion times too small. From the outside, these tunnels seem invisible. From the inside, they shape the laws of physics, but movement through them is impossible for beings built on our scale. Another way to imagine it is through the metaphor of the koi fish in a pond. The fish cannot leap into the sky unless something lifts it. It cannot move into a direction its body was never designed to navigate, not because the sky is far away, but because the fish's anatomy is bound to the plane of the water. Its world has a boundary, a ceiling it does not know how to cross. We are bound in a similar way, though our ceiling is not a surface, it is geometry. Your body, your atoms, your very being is woven from strings and fields that vibrate within the 3 large dimensions of space. Those vibrations cannot extend into the tightly curled directions that lie curled within each point. They simply do not have the required scale to explore them. Yet gravity, that faint ghost-like force, behaves differently. It does not bind itself as tightly to the three-dimensional brain we inhabit. It spreads, softens, and leaks into the surrounding hyperspace. This leakiness is one of the most compelling hints physics has that higher dimensions might exist. It explains why gravity is so weak compared to the other forces, why a simple comb can lift a piece of paper against the entire mass of the Earth. Gravity does not stay confined. It drifts into the hidden corridors we cannot enter. As you breathe slowly tonight, imagine that your body rests gently against the surface of a dimensional pond. You can move across it freely, explore every direction it offers, feel every current within it. But the directions beyond its surface remain quiet, sealed, softly folded away. They shape your world without letting you pass. We cannot drift into the hidden dimensions, not because they are distant, but because they are exquisitely small, woven too tightly for us to enter, yet close enough to influence everything we are. Now that we have explored the idea of hidden dimensions and the quiet ways they shape existence, we reach one of the most elegant possibilities in modern physics. The notion that our entire universe may be a membrane, a vast, three-dimensional sheet, floating gently within a larger, higher dimensional space. In physics, this sheet is called a brane, short for membrane. Not a metaphor, not an analogy, but a literal description of how reality may be structured. Imagine an enormous, flexible film stretching across an invisible ocean. On that film, stars ignite, galaxies swirl, planets drift, and life unfolds. Everything you know, your thoughts, your memories, your breath, exists upon this cosmic surface. To us, this brane is the whole world. It feels complete because we can move freely across it, forward and backward, left and right, up and down. But like a fish gliding through its pond, we may be confined to this membrane without realizing that a larger ocean surrounds it. In M-theory, this idea becomes profound. If our universe is a membrane, then gravity is not bound to it the way matter and light are. Photons, the particles of light, cling tightly to the brane. Electrons, protons, the forces that weave atoms together, all of them are anchored to this cosmic sheet. But gravity slips. Gravity roams. Gravity seeps out of the membrane and into the higher dimensional space around it. This gentle leak explains one of physics' greatest mysteries, why gravity is so weak. A comb can lift a sheet of paper, defeating the gravitational pull of the entire Earth. That seems impossible, unless gravity is spreading its strength across dimensions we cannot see, thinning itself like mist drifting through a wider landscape. Imagine touching the surface of a drum. The skin vibrates beneath your fingers, producing sound within the plane of the instrument. But press harder, and you feel the air beneath the drum, space beyond the surface, space that the vibrations can subtly reach. In a similar way, our universe may be the surface of a larger form, with gravity extending into the hidden depths below it. If this is true, then our universe is not isolated. It is embedded, floating in a cosmic ocean, surrounded by dimensions that our senses cannot reach. Supported by geometry we were never meant to perceive directly. A membrane drifting in what physicists call the bulk, the higher dimensional space that holds all branes within it. And then comes the most beautiful implication. If one membrane can exist in this ocean, why not others? Parallel branes, the entire universes, could hover just beyond our reach, separated not by distance, but by direction. Not elsewhere in space, but elsewhere in the fabric of reality itself. Like pages in a book, each universe could lie beside ours, close enough to touch if we only knew how to move in the necessary dimension. As you breathe slowly, imagine yourself lying on a soft, invisible surface, a cosmic membrane stretching beneath your body, supporting your world. Feel the quiet possibility that countless other membranes may drift alongside yours, carrying their own stars, their own lives, their own stories. You cannot see them, but gravity may whisper between them, faint and patient, the only messenger that knows how to slip between worlds. You live upon a membrane, a cosmic surface floating in a wider hidden sea. If our universe is a membrane drifting through a higher dimensional ocean, then it may not be alone. Just as a single ripple on a pond hints at the possibility of many others, our brain could be one of countless membranes suspended within the vast, unseen structure of the bulk. Each membrane could carry its own stars, its own galaxies, its own versions of physics, entire realities unfolding in parallel, yet forever out of reach because we cannot move in the direction that separates us. Imagine for a moment holding a stack of thin, transparent films. Each sheet lies so close to the next that you can barely feel the space between them. Yet each film is its own world, its own surface, its own complete layer. If you lived on one of these sheets, if your body, your atoms, your senses were bound to it, you would never touch the others. You would never even know they were there. Physicists imagine parallel universes in much the same way. Our brain could be one sheet in a layered cosmic structure, drifting alongside others that differ only by one hidden dimension. They might be inches away or miles away, or separated by no measurable distance at all, just direction. A direction your body cannot turn toward. Michio Kaku describes this beautifully. Universes may hover above or below ours, invisible not because they are far, but because light cannot travel between brains. If you shined a flashlight upward, its beam would glide harmlessly along the surface of our membrane, never slipping into the bulk, never illuminating the layers beyond. Light is confined. Matter is confined. Your very atoms are stitched to this cosmic sheet. But gravity is different. Gravity has no such leash. It can drift into the bulk, spreading its influence across the hidden dimensions. This means that brains can feel each other, not through light, but through subtle gravitational whispers. Some theories propose that what we call dark matter, the invisible mass-shaping galaxies, could be gravity leaking from a neighbouring brain, the pull of a parallel universe brushing gently against our own. Imagine another cosmos, just one dimension away, its stars glowing softly through a medium your eyes cannot detect. Imagine its galaxies rising and falling with their own histories, its physics unfolding on a timeline parallel to ours. Imagine its gravity spilling faintly into our world, guiding the motion of galaxies without ever revealing its source. As fantastic as it sounds, the mathematics is calm, clean, almost inevitable. If our universe is a brain, then other brains are not only possible, they are natural. A single membrane drifting alone would be the exception, not the rule. As you lie here tonight, breathe gently and imagine yourself resting on a page in a cosmic book. Other pages lie close, impossibly close, but the lines and letters on them are invisible to you. You share the same binding, the same deeper space, the same vast stillness. And every so often, through gravity's quiet leak, you feel the faint presence of the pages you cannot read. Other brains may drift beside ours. Other universes may shimmer just beyond perception. And though you cannot see them, their existence enriches the vastness of the world you inhabit. Your reality is one surface among many, a chapter in a larger cosmic story. If our universe is truly a membrane floating in a higher dimensional sea, then its story may be far more dynamic than we ever imagined. Membranes are not static. They can drift, they can ripple, and astonishingly, they can collide. In some cosmological models inspired by string theory and M theory, the Big Bang, the very birth of our universe, was not the beginning of everything, but the result of two brains brushing against each other in the vast quiet bulk. A cosmic collision, a gentle impact between two colossal invisible surfaces. Imagine two vast sheets slowly drifting through a silent ocean. For ages they glide peacefully, unaware of each other's approach. Then, in one quiet moment, they touch. The impact releases an unimaginable burst of energy, a flash bright enough to fill a universe, a rhythm strong enough to shape matter, time, and space themselves. From this single moment, a cosmos unfolds, galaxies spiral outward, stars ignite, planets form, and life awakens. Michio Kaku hints at this idea, that brains can move, vibrate, and even collide, giving birth to new universes in the process. It is a vision both grand and serene, creation not as a singular miracle, but as a natural consequence of higher dimensional geometry. In these models, our universe is not the first, not the only, not even necessarily the most recent. Cosmic history may be filled with cycles, brains drifting, colliding, recoiling, and drifting again. Each collision forms a new universe, each expansion a new chapter, each cooling a new canvas for stars and life to emerge. To us inside the brain, this collision would look like a single, brilliant moment, the Big Bang. We would not see the other membrane. We would not sense the motion that led to the impact. We would experience only the aftermath, a universe expanding, cooling, structuring itself into the world we now inhabit. But beyond our three-dimensional view, the event would appear different, slow, gentle, almost inevitable. Brains touch, energy flows, a universe blooms. This perspective does not diminish the wonder of creation, it deepens it. Instead of imagining our cosmos as a lonely miracle, we envision it as part of a larger living landscape, a place where universes themselves can be born, interact, and transform. Imagine, as you rest tonight, that our universe floats on a membrane still drifting through higher dimensional space. Imagine the quiet rhythm of that drift, the way a raft might move across a perfectly still lake. Imagine the possibility that other brains glide nearby, each carrying its own stars, its own physics, its own version of time. Perhaps someday, far beyond our lifetimes, our brain might ripple or brush against another, not with violence, but with the gentle inevitability of cosmic tides. And from that touch, another universe could begin, one that will expand, cool, and evolve into wonders we cannot imagine. Creation, in this view, is not a single event. It is a pattern, a quiet, profound dance between membranes drifting through the higher dimensions. Your universe may be just one step in this endless dance, a moment of light in a larger unfolding symphony. Light is one of the most honest storytellers in the universe. It travels straight unless the geometry of space bends it. It moves at a constant speed unless time itself changes pace. It paints the shapes of galaxies, traces the curves of gravity, and reveals the texture of the cosmic fabric long after other signals fade. If anything in nature could hint at the presence of higher dimensions, it would be light, the quiet messenger that records every contour of reality. In our three-dimensional world, light moves along the paths carved by space-time. When it passes near a massive object, its trajectory bends gently, like a ribbon following the curve of a riverbank. This bending is what lets us see distant galaxies magnified by gravitational lensing, nature's own telescope, shaped by the geometry of the cosmos. But imagine if space-time itself were shaped not only by the three dimensions we know, but by hidden directions curling softly just beyond our senses. What would light do then? How would it navigate a world with more corridors than we can observe? In higher dimensional models, the geometry of space becomes richer, more complex, more layered. A beam of light travelling through such a landscape would still follow the straightest path available, but that path might weave subtly through structures we cannot perceive. It might ripple around curled dimensions, trace arcs carved by unseen geometry, or drift through regions where gravity flows into hidden directions. Light becomes a whisper of the dimensions it cannot enter, but consents. Think back to Michio Kaku's metaphor of smoke filling a room. Smoke spreads into every corner, but it never drifts into the fourth dimension because the opening is too small. Light behaves similarly. It travels only along the three large directions of our universe. The curled dimensions are there, everywhere, but their doorways are too narrow for light to enter. Still, the presence of these dimensions leaves a signature. They shape the overall geometry of the cosmos, and light must bend around whatever geometry exists. Just as a shadow can hint at a shape you cannot see directly, the way light moves can hint at dimensions that remain hidden. Some physicists believe that the subtle patterns in cosmic microwave background radiation, the faint afterglow of the Big Bang, might contain traces of higher dimensional influence. Others suggest that the bending of light around black holes, or the way gravity shapes galactic structures, could reveal clues about the hidden architecture beneath our universe's surface. But even without experimental evidence, the idea itself is beautifully simple. Light follows geometry, and geometry may extend into dimensions we cannot perceive. As you lie here tonight, imagine a beam of starlight drifting across the universe. It travels through billions of years and billions of miles with perfect grace. It glides past galaxies, skirts the edge of black holes, and threads through the silent fabric of space-time. It never enters the hidden dimensions, but it feels them. It senses their curves. It follows the path carved by the full structure of reality, not just the part visible to us. You too move through this structure without noticing it. You breathe within it. You sleep within it. And every particle in your body is shaped by the same geometry that guides the light of distant stars. Light shows us that the universe is deeper, more layered, more eloquent than our senses reveal, a reminder that hidden dimensions may touch everything, even if they never appear to our eyes. If you could shrink yourself down, smaller than a speck of dust, smaller than a virus, smaller even than a single atom, you still would not reach the end of nature's structure. Within the atom lies the nucleus. Within the nucleus, quarks hum in restless patterns. And if modern physics is right, within every particle lies something deeper still. Loops, strings, and pathways leading into curled dimensions folded too tightly for the human mind to picture. At this unimaginably small scale, particles are not simply points. They move through hidden corridors. They trace loops inside compactified dimensions. They vibrate in shapes sculpted by invisible geometry. Their behavior is not random. It's choreographed by the extra dimensions curled within the fabric of space. Michio Kaku once described this with a quiet elegance. These dimensions are smaller than atoms, smaller than any particle we know. Nothing can drift into them, not smoke, not molecules, not even electrons. And yet particles must sense them, because their quantum vibrations depend on the shapes of these hidden spaces. Imagine a violin string. Its sound changes depending on the shape of the wooden chamber that surrounds it. A narrow chamber yields a thin tone. A wide chamber gives depth. The chamber does not vibrate itself, but it shapes the vibration. Now imagine the universe itself as that resonant chamber. The curled dimensions, silent, invisible, impossibly small, shape the tone of every vibrating string. They determine the properties of particles. They dictate how matter interacts. They whisper the rules of reality. If the extra dimensions had different shapes, if they curled in different ways, the universe would be profoundly altered. Electrons might have different masses. Quarks might bind differently. Atoms might not form at all. The stars, the galaxies, the chemistry of life, everything would shift. This means that higher dimensions are not distant curiosities. They are the hidden blueprints of existence. Every so often, experimental physicists search for subtle signs of these curled dimensions. They look for tiny anomalies in particle collisions, small missing energy events that might indicate a particle slipping momentarily into a hidden pathway. They look for deviations in gravitational behavior. They look for symmetry patterns that hint at unseen geometry. So far, the curled dimensions remain silent. But silence is not absence. It is simply subtlety. As you breathe gently, imagine the particles in your body, trillions upon trillions of them, each carrying within it a tiny map of hidden dimensions. Imagine the electrons orbiting your atoms, their quantum paths shaped by curled spaces smaller than imagination. Imagine the quarks inside your cells, tracing loops through dimensions rolled tightly into every point. You cannot see these dimensions, you cannot travel through them, but you are built from their influence. Every heartbeat, every thought, every breath is orchestrated by physics unfolding far beneath your perception. Physics shaped by the silent, curled architecture of higher dimensions. The next time you place your hand on your chest and feel your heartbeat, remember, even that rhythm is guided in part by the geometry of spaces you will never see, woven softly into the foundations of everything you are. If higher dimensions truly shape our universe, if they guide the vibration of particles, soften the strength of gravity, or cradle our entire cosmos like a membrane in a wider sea, then a gentle question follows. Could we ever detect them? Not through imagination or metaphor, but through experiment. Through the quiet, careful instruments humans build to listen to the universe more deeply than our senses allow. For now, the hidden dimensions remain silent. Not because they are shy, but because they are small, so tightly curled that no particle we know can slip inside them, no beam of light can illuminate them, no microscope can magnify them. They hum below the quantum scale, delicate as threads woven into the smallest crevices of existence. And yet, physics suggests ways we might someday hear their whisper. One approach begins with gravity, the weak, ghost-like force that seems strangely diminished compared to the others. A comb can lift a sheet of paper against the pull of the entire Earth. An electron can bind a hydrogen atom with far more strength than gravity could ever muster. Why is gravity so faint? One possibility is that gravity is leaking into the higher dimensions. If so, then at extremely small distances, gravity might grow stronger, deviating from its familiar behavior. Physicists test this with exquisitely sensitive instruments, tiny weights suspended near one another, their motion tracked by lasers, searching for the faintest hint that gravity behaves differently at microscopic scales. A gentle anomaly, a small deviation, a clue. Another approach comes from particle accelerators. If particles collide with enough energy, one might momentarily slip into a hidden dimension, taking some energy with it. To our detectors, the collision would appear to lose energy mysteriously, as if a piece of the event simply vanished. Not destroyed, not hidden, just shifted into a direction our machines cannot detect. So scientists watch for missing energy patterns, tiny disappearances that could reveal pathways into the curled dimensions deep within the fabric of reality. Then there are gravitational waves, rippling through space-time like soft tremors through a vast ocean. If higher dimensions shape the structure of the universe, these waves might carry subtle signatures, slight distortions, unexpected echoes, patterns that do not quite match a purely three-dimensional world. Our detectors are not yet sensitive enough to distinguish these whispers, but each new improvement brings us closer. Even the cosmic microwave background, the faint afterglow of the Big Bang, could contain hints of higher dimensional geometry. Tiny irregularities in its temperature might reflect the shape of the universe at its birth, when the hidden dimensions were not yet fully curled. By reading these patterns like fossils in ancient rock, we may uncover the memory of a time when extra dimensions flowed more freely. But the most profound possibility lies not in the present, but in the future. As our technologies grow quieter, more precise, more sensitive to the universe's faintest tremors, the boundary between what is detectable and what is hidden begins to soften. The instruments of tomorrow may illuminate what today lies forever in shadow, and yet, even without direct evidence, the idea of higher dimensions offers something meaningful. Not certainty, but wonder. Not proof, but possibility. A reminder that our understanding of reality is always expanding, always unfolding, always becoming richer than it was before. As you breathe gently tonight, imagine the scientists of the future listening to the universe with instruments finer than the human ear, finer than the human eye, devices that can sense the slight ripples of gravity, the softest echoes of creation, the faint signatures of dimensions curled inside every particle. Perhaps someday these whispers will speak loudly enough for us to hear. Perhaps someday the hidden dimensions will no longer be hidden. For now, they remain possibilities, quiet, patient, waiting to be discovered. There is a gentle truth at the heart of higher dimensional physics. Most of the structures that govern our universe cannot be pictured by the human mind, not because they are too strange, or too abstract, or too distant, but because our brains evolved inside a three-dimensional world. We imagine in length, width, and height, because those are the directions our bodies move. Those are the axes our eyes trace. Those are the boundaries our ancestors needed to survive. And so, when physics suggests that the universe may be built from shapes that require 6 or 7 extra dimensions to even exist, our intuition quietly hesitates. The mind tries to stretch itself, reaching into unfamiliar territory, only to find that the mental canvas itself is too narrow. It is like trying to paint the sky on a sheet of paper that is just a little too small. The picture will always fall short. Mathematicians can describe these higher dimensional forms with precision. They can write equations that capture every twist, every curvature, every silent fold. They can manipulate these shapes symbolically, watching them change, bloom, and collapse under the logic of algebra and geometry. But no one, not even the greatest physicists, can truly visualize them. Michio Kaku often speaks of these hidden dimensions as spaces curled so tightly that they slip beyond perception. Their geometry is intricate, complex, multi-layered, like origami folded from a sheet you can never unfold, or like a cathedral carved inside a grain of dust. A structure so elaborate yet so small that it lies forever beyond intuition. One popular model uses Calabi-Yau spaces, exquisite multi-dimensional forms that guide how strings vibrate. These shapes determine the properties of particles, the masses of electrons, the strength of forces, the very chemistry that allows stars to burn and life to form, all from geometries we cannot see, but that shape everything we are. Imagine, just for a moment, a tiny chamber curled inside every point of space. Not a room with walls or corners, but a delicate labyrinth of directions the mind cannot follow. Inside that chamber, a string vibrates, humming a note that defines a particle's identity. Change the chamber's shape, and the note changes. Change the note, and the universe reshapes itself. It is astonishing to realize how much of reality is built upon structures we can't picture, and yet there is grace in this limitation. Our inability to visualize higher dimensions is not a failure. It is an invitation to humility. It reminds us that the universe is not obliged to fit within the boundaries of our imagination. It asks us to accept that truth can be larger than intuition, deeper than vision, broader than thought. As you breathe gently tonight, feel the comfort in not knowing. Feel the quiet wonder of living inside a universe whose architecture surpasses your senses. You do not need to visualize these higher dimensional shapes for them to exist. You do not need to understand their geometry for them to shape every atom in your body. Your inability to picture them is simply a sign that you are human, a three-dimensional being dreaming your way through a many-dimensional world. And perhaps that is enough. When we reach the limits of human intuition, something remarkable steps in to guide us: mathematics. It is the lantern we carry into regions our senses cannot enter, the bridge we use to cross from what we know into what might be. In everyday life, math feels like a tool, something practical, structured, finite. But in the quiet world of theoretical physics, mathematics becomes something far more profound, an extension of imagination, a sense organ for truths we cannot visualize. Think of how limited our perceptions truly are. We cannot see atoms, we cannot hear gravitational waves, we cannot feel the curvature of space-time, and we cannot picture 6 or 7 extra dimensions no matter how hard we try. Our intuition simply has no foothold there, and so, where our imagination falters, mathematics grows wings. It allows us to see structures our minds cannot picture. It allows us to navigate spaces beyond the 3 directions we know. It lets us model phenomena that have no ordinary analogy. The shapes of Calabi-Yau manifolds, the vibrations of strings, the curl of compactified dimensions. Mathematics does not require our intuition to understand these objects. It simply describes them, and in doing so, it reveals a universe that is far richer than anything our senses alone could uncover. Michio Kaku often emphasizes this. Higher dimensions are not guesses. They are demanded by the equations themselves. Mathematics insists upon hidden directions, curved spaces, and vibrating strings. It insists upon a universe whose beauty surpasses our ability to picture it. This is not a kind of fantasy. It is a kind of clarity. Imagine trying to describe a sphere to a flatlander living on a sheet of paper. No matter how you explain it, they will not see the sphere. Their world allows no such shape. But the equations describing a sphere are simple, elegant, undeniable. The flatlander might not visualize it, but they can understand it if they follow the mathematics. We are the flatlanders now. Higher dimensional geometry is the sphere we cannot picture, and mathematics is the language through which the universe whispers its structure to us. When physicists write the equations of string theory, or M theory, they are not drawing pictures. They are listening to symmetries, to harmonics, to algebraic relationships that speak of hidden rooms in the architecture of reality. The equations tell them how many dimensions are needed. They tell them how those dimensions must be curled. They tell them what shapes can support stable universes and what shapes collapse instantly back into chaos. Math is not simply a description of reality. In many ways, it reveals reality. As you breathe slowly tonight, imagine mathematics not as numbers or symbols on a page, but as a soft light illuminating the unseen, a lantern revealing corridors your senses cannot follow, a quiet bridge between the world you know and the deeper world that holds it. You do not need to visualize 10 dimensions to appreciate their possibility. You do not need to imagine curled manifolds to believe they might exist. The mathematics already imagines them for you, carrying your mind where your intuition cannot go. It is the gentle imagination of the universe itself, a reminder that truth can extend beyond vision, and knowledge can flow even where imagination stops. If higher dimensions truly shape our universe, if they hum through particles, soften gravity, and cradle our cosmos upon an invisible membrane, then a quiet question arises. Do they touch our everyday lives, not just through equations or theories, but through the gentle rhythms of existence itself? In a way, they do. Though we cannot walk into these hidden directions or sense their curvature, the influence of higher dimensions ripples softly through everything we know. Reality is a tapestry woven from threads we cannot see, yet those threads are present in every breath you take, every thought you form, every moment you drift through. Consider sound. Although it moves through ordinary space, its harmonies hint at deeper structures. When a violin plays, the richness of its tone comes not only from the string, but from the hidden space within the instrument, small, curved, resonant chambers that shape the sound. You do not see those chambers while listening, yet their influence is undeniable. Hidden structure shaping familiar experience. The universe behaves similarly. The curled dimensions, silent, compact, invisible, shape the vibrations of the strings inside every particle. Without them, matter as we know it would not form, atoms would not bind, stars would not shine, and the chemistry of life would collapse. You owe your very existence to directions of space you will never enter. Even the weakness of gravity, a force so gentle you can lift objects against the pull of an entire planet, is a clue. Gravity may be diffusing into the higher dimensions, spreading its influence across a larger geometry than we perceive. It behaves as if it has more space to wander than the other forces do, whispering to us that there is more to the universe's structure than meets the eye. But higher dimensions also touch life in gentler, more metaphorical ways. Consider memory. Thoughts do not exist in simple lines or layers. They branch, echo, intermingle. Memories drift through emotional space, sensory space, conceptual space, dimensions of meaning rather than geometry. Your inner world is multidimensional, even if your physical body is not. Consider time. Although we experience it as a one-way flow, your mind can leap backward through memories, forward through imagination, sideways through dreams. Your consciousness is not bound by the dimensions your body inhabits. It drifts in its own quiet landscape, shaped by pathways more fluid than physical space allows. Consider emotion, joy, sorrow, longing, peace. These states do not fit neatly into length, width, or height. They unfold in internal coordinates that have no physical direction but feel entirely real. In this sense, your inner life already extends beyond the physical dimensions you can measure. Some philosophers suggest that human intuition evolved to navigate a three-dimensional world, but human consciousness evolved to explore something far larger. Your thoughts, your dreams, your inner depths may hint at the flexibility of a mind built inside a multi-dimensional universe, not by perceiving the hidden dimensions directly, but by resonating with the complexity that those hidden dimensions allow. As you breathe softly tonight, imagine that higher dimensions are not distant alien realms, but quiet companions woven into the background of your life. They shape the atoms in your body. They influence the forces around you. They whisper through every interaction, every heartbeat, every moment of being. You cannot see them. You cannot walk through them. But you live within a universe sculpted by them, a universe whose hidden depth makes your existence possible. In that sense, higher dimensions are already part of your everyday life, flowing through reality in ways both subtle and profound. When you look at your shadow on the ground, you see a simple outline, a flat, two-dimensional echo of your three-dimensional form. It moves when you move. It stretches and shrinks depending on the light. It hints at your shape, your motion, your presence, but it is not you. It is a projection, a reduced version of something richer. Physics suggests the universe may behave the same way. What you see around you, the stars, the galaxies, the shimmering web of cosmic structure, might be the shadow of a deeper, higher dimensional world. Not in a metaphorical sense, but in a precise mathematical one. A lower dimensional projection of something larger, folded and unseen. This idea is known as the holographic principle. It whispers that everything inside our universe, every field, every force, every atom, could be encoded on a distant surface, much like a hologram encodes a three-dimensional image on a flat sheet. In this view, our reality is not diminished. It is simply one manifestation of a deeper structure. Imagine a book. When you read it, you experience a world of characters, places, events, and emotions. But all of it, the depth, the meaning, the colour, is encoded on thin, flat pages. Two-dimensional ink bringing to life a multi-dimensional story. Now imagine that our universe might be such a story. Some physicists believe that the information of our world may be woven into a distant boundary in higher dimensional space. Everything we experience could emerge from the gentle unfolding of that information into a familiar three-dimensional form, the same way your mind creates depth from a flat page. Michio Kaku often describes the universe as a kind of shadow of higher dimensional reality, a projection shaped by geometry we cannot access directly, not because our world is less real, but because the deeper world is more spacious. If our universe is a projection, then the room in which it exists must be vast, quiet, and deeply layered. Light would move across its surface the way ripples move across a pond. Gravity might seep from higher dimensional depths into our visible world. The laws of physics, the speed of light, the strength of forces, the mass of particles, could emerge from the structure of that hidden surface. Think of a shadow once more. It captures some truths, but not all. It reveals shape, but not texture. Motion, but not depth. Similarly, our universe might reveal only a portion of the higher dimensional structure that gives rise to it. You are living within that shadow, a three-dimensional story unfolding on the surface of a deeper reality. As you breathe softly tonight, imagine yourself as part of a hologram woven gently through space. Your atoms are patterns in the projection. Your thoughts are ripples in the geometry. Your life is a movement within the illuminated outline of a larger shape. This does not diminish you, it expands you. It suggests that your existence is connected to a greater realm, one whose presence is felt in every law of nature, every motion of particles, every corner of the sky. Perhaps the universe you know is just the beginning. Perhaps it is the visible edge of a much grander design. A projection, yes, but one cast from a reality more intricate, more expansive, and more beautiful than you could ever imagine. If the universe is a projection, a membrane, a vibrating tapestry woven through hidden dimensions, then what does that make you? Are you merely a three-dimensional creature drifting through a narrow slice of reality? Or could you, in some quiet and subtle way, be connected to the larger dimensional structure that gives birth to the world you know? Physics suggests an intriguing possibility. You may be shaped by dimensions you cannot sense, influenced by spaces you cannot enter, and connected to structures that lie just beyond the reach of awareness. Your atoms vibrate in patterns determined by hidden geometry. Your body's stability arises from quantum rhythms unfolding in curled dimensions. Your consciousness blossoms from physical processes shaped by space that extends beyond your intuition. You live in 3 dimensions, but you are built from many. Imagine a violin crafted from wood carved into a resonant chamber. The music you hear comes from the strings, yet the richness of the sound comes from the chamber you never see. Your body is similar. Your thoughts arise from neurons, but the physics of those neurons is shaped by the hidden dimensions folded within each particle inside you. The architecture of your existence extends into deeper spaces, the same way the sound of a violin extends into the hollow within it. You are not merely in the universe, you are the universe, expressed through a human form. Even your inner world hints at multidimensionality. Your memories do not lie along a straight line, they form constellations, clusters of meaning, emotion, sensation, and experience. Your imagination does not move in a single direction. It leaps sideways through memory, forward into possibility, downward into feeling, upward into hope. Your consciousness travels through realms that have no physical coordinates, but feel spacious nonetheless. In dreams, you drift through landscapes that defy logic, bending time, folding space, changing shape. Your mind plays with dimensions even if your body cannot. A dream can stretch a second into an hour. It can place you in 2 places at once. It can unfold in ways that feel strangely akin to higher dimensional motion. Perhaps consciousness is not bound by the narrow geometry of physical space. Perhaps it resonates with the complexity of a multidimensional universe. Not by moving through curled dimensions directly, but by arising from the physical processes shaped by them. Your thoughts may be shadows of higher dimensional harmonics, just as physical objects may be shadows of higher dimensional forms. Michio Kaku often speaks of the idea that the mind itself is an emergent phenomenon of a universe built on extra dimensions, that consciousness may reflect the same complexity, the same layered structure, the same hidden harmonies that define the cosmos. If the universe is multidimensional, perhaps the mind is too. Not literally in spatial directions, but in its ability to hold layers of meaning, emotion, memory, and awareness simultaneously. As you breathe gently tonight, consider the possibility that you are more than a three-dimensional shape resting on a bed. You're a pattern woven through the fabric of space-time. You're vibrations shaped by hidden geometry. You're an expression of a deeper reality, folded elegantly into the visible world. You are not separate from the extra dimensions. You are a reflection of them. Being shaped by invisible corridors of existence, carrying their influence in every atom, every thought, every heartbeat, you are a multi-dimensional being, living in a three-dimensional dream. For all the wonder we feel when contemplating extra dimensions, there is a softer, more intimate truth that flows beneath the surface. Our perception of the world is not the world itself. It is a map, useful, beautiful, but incomplete. Just as a sketch cannot capture the fullness of a landscape, our senses cannot capture the fullness of reality. There are edges to what we can know through sight, sound, touch, and intuition. Edges that mark the boundaries of a human body designed to navigate a three-dimensional world. And yet, within these edges, we sense hints of something more. Faint ripples of a deeper structure, glimpses of patterns our minds were never trained to see. Consider light. Your eyes detect only a narrow band of the electromagnetic spectrum, the colours of a rainbow, and nothing more. But the universe glows with infrared warmth, ultraviolet fire, X-ray storms, and microwave whispers. Your senses edit reality, not because they are flawed, but because they evolved to reveal only what mattered for survival. Consider sound. You hear the mid-range hum of human speech, the rustle of leaves, the settling of distant rain, but you do not hear the bass notes of continental plates grinding beneath the earth, nor the high-pitched cries of molecules vibrating, nor the symphony of gravitational waves singing as black holes merge. The world is so much larger than your senses allow. Now consider your thoughts. When you close your eyes, your mind begins to drift. It wanders through memory, imagination, feeling, and intuition, none of which occupy physical space. These internal movements have no coordinates, no length or height, no measurable mass. Yet they feel real. They unfold as vividly as landscapes, carrying you through silent corridors that cannot be mapped in physical geometry. Dreams, too, defy dimension. In dreams, you move in ways that break physics. You drift through walls, rise from the ground, witness scenes that blend past and future. Your sleeping mind ignores the limits of three-dimensional motion, because those limits were never encoded into consciousness, only into the physical body that houses it. Perhaps perception itself is a thin boundary, the surface of a deeper sea. Michio Kaku often describes humans as flatlanders, beings confined to their sensory pond, unaware of the vast reality above and around them. We look outward, thinking we see the universe fully, but we are seeing only the slice our biology allows. Every sense is a window, and every window is small. The quiet edges of perception remind us that mystery is not evidence of absence. It is evidence of limitation. A limitation shared by every creature, every species, every mind that has ever opened its eyes within this universe. As you breathe slowly, let yourself settle into this sense of humility. Your experience of the world is real, but it is not complete. It is a layer, a thin, shimmering membrane through which a deeper reality glows faintly. You do not need to see the extra dimensions to be part of them. You do not need to feel them to be shaped by them. You live inside a universe that extends beyond every boundary of perception, and yet you move through it with perfect grace, guided by senses tuned for a small but meaningful slice of truth. The quiet edges of perception remind you of something profound, that wonder begins where sight ends, and that the parts of reality you cannot see may be the most beautiful of all. Close your eyes for a moment and imagine what it would be like to step outside the limits of human perception, not to escape your body, but to rise gently above the constraints of three-dimensional sight, to see reality not as a sequence of moments, but as a whole, a tapestry woven from time, space, and dimensions beyond anything your eyes were built to witness. What would it mean to see everything at once? Imagine looking at your own life not as a chain of memories, but as a luminous path laid out across the landscape of space-time. Birth, childhood, wandering, learning, heartbreak, healing, all visible as shimmering points along a single glowing thread. Past and future no longer separated, but part of the same shape. A being who can move freely through higher dimensions would see this effortlessly, the way you see an entire painting at a glance. Now imagine seeing the lives of others the same way, their journeys branching, merging, drifting apart, rejoining in unexpected ways, every choice forming a subtle curve, every moment adding a small twist to the geometry of their path. From a higher dimensional perspective, these curves would be visible, elegant, interconnected, and not just the lives of people, but the lives of stars. A higher dimensional being might see a star's entire existence as a single structure, a cloud collapsing, a sphere igniting, a bright middle age, a fading glow, a soft drift into a nebula. To such a being, a supernova would not be a sudden explosion. It would be an intricate turn in a radiant sculpture made of time and energy. Even galaxies, those enormous spirals of starlight, would no longer be swirling disks but four-dimensional formations, like frozen fireworks captured in a shape the human mind cannot picture. Consider the koi fish again. If it were lifted into the third dimension, it would see its pond from a perspective it never knew existed. The ripples it once understood as simple lines would suddenly reveal themselves as circles. Depth would become real. Motion would gain new meaning. Now imagine the same transition, inward, not upward into the third dimension, but outward into a fifth, sixth, or seventh. A shift so profound that the geometry of your world reveals new layers, new curves, new relationships that were invisible all along. You would see gravity drifting through dimensions like a soft breeze bending invisible grass. You would see light weaving along paths carved by higher dimensional shapes. You would see the curled dimensions inside every point of space, tiny labyrinths guiding the vibrations of strings, shaping the properties of matter, forming the silent blueprint of the cosmos. And perhaps most astonishingly, you would see how everything is connected, not metaphorically, literally. Because in a higher dimensional view, separations become illusions, distances shrink, boundaries dissolve. The fabric of reality folds in ways that unite the far away and the near, the past and the future, the small and the vast. As you breathe softly tonight, imagine standing at the threshold of this expanded view, not stepping through it, but sensing its presence. Feel the wonder of a universe where every moment has a place, every life has a shape, and every pattern is part of a larger hidden geometry. You cannot see all dimensions at once, not with human eyes, but you can imagine the possibility. And in that imagination, the universe feels just a little wider. When you look around your room, the space appears simple, open, smooth, quiet. But physics suggests something far more wondrous hiding beneath this calm surface, that each point in space, every invisible dot between your fingers, every whisper of air around your body may contain an infinity of structure folded into it. not metaphorical infinity, literal geometric richness, curled into dimensions too small for any eye to see. Imagine taking a single point of space and magnifying it 1,000 times. You would reveal atoms, magnify again, and you would find protons, neutrons, quarks. Magnify further, and you might reach strings, tiny vibrating loops of energy, humming with the rhythms that form every particle in existence. But if you could magnify even deeper, the view would grow stranger. The point would not become empty. It would not flatten into nothingness. Instead, the tiny loops of extra dimensions would begin to unfurl, curled corridors, spiraled chambers, geometric tunnels twisted into shapes the mind cannot visualize. This is the quiet miracle of compactified dimensions. The universe hides entire landscapes inside spaces so small they defy imagination. Michio Kaku describes these hidden dimensions as being smaller than atoms, smaller than quarks, smaller than anything we have ever measured. If they were larger, matter would drift into them, but they remain curled tightly, holding their complexity within boundaries too narrow to enter. And yet, despite their smallness, they shape everything around you. They determine how strings vibrate, which determines how particles behave, which determines how atoms form, which determines how stars ignite, which determines the chemistry of life. All of this, the sweep of galaxies, the pulse of suns, the breath in your lungs, emerges from the quiet geometry folded into each point of space. In this way, infinity hides within the smallest things. Imagine holding a grain of sand. To your eyes it is tiny, simple, inert. But buried inside that grain, and inside every grain around it, are layers upon layers of hidden dimensions, structured more intricately than any cathedral. A cosmos nested within a cosmos. The ancient mystics once said that the universe could fit inside a single point. Modern physics, in its own poetic language, suggests something similar, that the architecture of reality is fractal, layered, infinite in depth, even if finite in size. And these infinite layers are not distant. They are with you now, in the space between each heartbeat, in the particles that compose you, in the quiet stillness of the room where you rest. Think of how remarkable that is. You live at the surface of a world that is infinitely deep. You walk through space that is richer than any landscape on Earth, richer than any starfield, richer than any dream. Outside, the night sky seems vast, stretching across light years and galaxies. But inside each point of space, beneath the level of atoms, lies a depth far greater, a universe within the universe. As you breathe slowly tonight, imagine that each inhale draws in not empty air, but the subtle presence of unseen dimensions. Imagine that the quiet around you is full of hidden geometry, folded so delicately that it shapes your very existence. Infinity is not far away. It is here, tucked gently inside the smallest places, in every point of space you have ever touched, and in every point you never will. There is a quiet idea that drifts through both physics and philosophy, that consciousness itself may hint at dimensions our senses cannot perceive. Not because the mind literally moves through hidden spatial directions, but because awareness behaves in ways that do not map cleanly onto the 3 dimensions of everyday life. Your thoughts do not exist in length, width, or height. Your memories do not lie in coordinates on a map. Your emotions cannot be contained inside a geometric shape. Instead, your inner world unfolds in a landscape that feels spacious, fluid, and layered. A place where you can move effortlessly between past and present, between what is real and what is imagined, between what is felt and what is remembered. This inner motion is a kind of dimensional flow. Consider how your mind drifts when you close your eyes. You can jump from childhood to last week to tomorrow's worries in a single breath. You can replay an entire lifetime in a moment, or sink into a single memory so deeply that the rest of the world dissolves. You can imagine places you've never seen, feel emotions tied to nothing but possibility, and build entire worlds within the soft darkness behind your eyelids. None of this requires physical space. None of this obeys the geometry of the room around you. It is thought moving through its own dimensions. Physicists rarely speak of consciousness directly when discussing higher dimensions. Yet there is a shared theme: complexity emerging from simplicity, patterns arising from hidden structure, meaning unfolding from spaces too subtle to visualize. Michio Kaku often reflects on the idea that the mind may be shaped by the same physics that governs the universe, that consciousness is not separate from the cosmos, but a natural expression of the laws that weave through every dimension. If the universe has hidden layers, perhaps the mind grew to reflect them, even if we do not sense them literally. Think of the brain. Billions of neurons, trillions of connections, patterns of activity weaving in every direction. At any given moment, countless signals ripple through your neural network, interacting, branching, merging, forming the delicate choreography of thought. This choreography does not occur in a line. It blooms across many axes at once: logical, emotional, sensory, abstract. You're always experiencing multiple layers of reality simultaneously: your physical surroundings, your memories, your interpretations, your hopes, your fears. Your awareness is already multidimensional in a way the body is not. And there is a quiet beauty in this. Even if your senses cannot perceive the hidden dimensions of space, your mind may still echo their complexity, not by travelling through curled geometry, but by holding many kinds of information at once, like a higher dimensional being who sees multiple perspectives effortlessly. As you breathe slowly tonight, feel your mind flowing through its own gentle landscape. Notice how each thought opens into another, how each memory carries emotional depth, how each feeling moves in directions that physical space cannot capture. Your consciousness is not bound by 3 dimensions. It stretches, folds, loops, and drifts through a world of its own making. A world shaped by meaning rather than geometry. A world where time is fluid, space is metaphorical, and experience unfolds like a quiet, multi-dimensional tide. In this sense, you're already a traveller through hidden dimensions, carrying within you the subtle complexity of a universe much larger than the one you see. If you close your eyes and listen closely, the universe begins to feel less like a machine and more like a piece of music, a vast composition unfolding across space and time, shaped by rhythms too slow for human ears and harmonies too subtle for human senses. Stars pulse, galaxies swirl, particles vibrate, and space-time curves with a softness that feels almost melodic. Physics, at its most poetic, suggests that this cosmic music may be conducted across many dimensions. Every force, every particle, every law of nature becomes a note in an enormous multi-dimensional chord. Gravity plays the deepest tones, soft and resonant, vibrating across vast stretches of space-time and leaking gently into hidden dimensions. Electromagnetism adds shimmering harmonics, bright and quick, dancing through the familiar 3-dimensional world. The nuclear forces strike sharper chords, binding the smallest pieces of matter in fierce rhythmic pulses. And underlying them all are the strings, the tiny loops of energy described by string theory, humming with frequencies shaped by curled dimensions folded inside every point of space. Each vibration is a note, each particle is a tone. The universe is the symphony they create. Imagine standing inside a grand concert hall. You hear the instruments directly, but you also hear the resonance of the hall itself, the shape of the room shaping the sound. In a similar way, the hidden dimensions act as the resonant chamber of reality. They do not simply exist. They shape the entire symphony of physics, determining which notes can play and which cannot. Michio Kaku often speaks of this quiet harmony, the idea that when all the forces of nature are understood together, they form a single, unified song, a melody that becomes audible only in higher dimensions, where the broken pieces of physics, gravity, quantum mechanics, electromagnetism, finally fit into one coherent score. In his view, the superforce of the early universe was not chaos but perfect music, a crystal of laws vibrating as one. Only later did the crystal shatter, scattering its melody into the separate forces we now observe. But the harmony remains hidden inside the geometry of higher dimensions. If you could perceive all dimensions at once, you would not see chaos. You would see harmony. You would see the universe as a single composition, its movements shaped by structures too delicate for ordinary perception. Even now, you can feel traces of this harmony in the world around you. The rising and setting of the sun, the tide pulled by the moon, the gentle pattern of your breathing, the rhythm of your heartbeat, all echoes of deeper cycles, a reminder that you are part of the same cosmic score. As you rest tonight, imagine the universe as a great instrument, struck once in the moment of creation, still vibrating across dimensions, still resonating through the atoms of your body. Your existence is not separate from this symphony. You are a note within it, a quiet tone carried by the same laws that guide galaxies and stars. Let this thought soothe you. Even amidst the vastness, you are part of something harmonious, something ancient, something still unfolding. The universe is a dimensional symphony, and you are listening from within the music. There is a quiet place where science, imagination, and wonder begin to blend, a place where the boundaries of knowledge soften like the horizon at dusk. When we speak of extra dimensions, we're not only exploring physics, we're exploring the shape of the unknown itself, and in that unknown there is room for reflection, for dreaming, for a feeling of deep and gentle possibility. Consider the horizon you see when you stand by the sea. It looks like the edge of the world, the place where sky meets ocean in a perfect line. But you know it is not truly an edge, it is simply the limit of what your eyes can see. Beyond it, the world continues, other waves, other winds, other distant shores. In the same way, our perception of reality forms a horizon. We look outward with our senses, and the universe appears to end where our intuition falters. But that edge is not an ending. It is an invitation, a quiet suggestion that something lies beyond, not in distance, but in dimension. Michio Kaku often speaks of humans as creatures who live in a dimensional pond, unaware of the vastness that surrounds us. Just as the koi fish does not know the sky until it is lifted into it, we may not know the full structure of reality until our understanding is lifted beyond our familiar senses. The unknown is not a void. It is a larger sky waiting above our pond. Dreams, too, hint at this larger sky. When you sleep, the boundaries of your world soften. Time becomes fluid. Space reshapes itself. Walls dissolve. People appear and disappear. You drift through landscapes that do not obey the physics of waking life. Night after night, your mind enters dimensions of experience that lie just outside the rigid structure of the day. These dreamscapes are not literal higher dimensions, but they reveal something important. Your consciousness is not confined to the geometry of physical space. It moves freely through meaning, memory, emotion. It expands into realms that cannot be measured with rulers or mapped with coordinates. Your inner life already knows how to drift beyond the horizon. And then there are the horizons of science, the unanswered questions that stretch across the cosmos like silent shorelines. Why is gravity so weak? Why do the laws of physics seem fine-tuned for life? Why does the universe exist at all? Each question is a horizon, and beyond each horizon may lie hidden dimensions, parallel brains, or geometries we have not yet imagined. There is beauty in this uncertainty, not the beauty of ignorance, but the beauty of an ocean whose farthest waves we cannot see. The unknown gives the universe its poetry, its sense of depth, its quiet invitation to keep looking, keep wondering, keep dreaming. As you breathe slowly tonight, feel the soft pull of that invitation. You do not need answers to rest peacefully in the mystery. You do not need certainty to appreciate the beauty of possibility. The horizon of knowledge will always move as you approach it, not to deny you, but to encourage the gentle expansion of your curiosity. Beyond that horizon lies something wider, deeper, softer, not frightening, but full of promise. The unknown is not emptiness. It is simply the part of the universe we have not yet learned to see. There is a quiet freedom that comes with exploring ideas as vast as extra dimensions. A freedom not of movement, but of perspective. You may never walk into a hidden direction of space. You may never float between brains or glimpse the curled geometry beneath reality. But you can let your mind drift beyond the boundaries of what is known. And sometimes that freedom is the most powerful part of discovery. Science does not ask us to believe impossible things. It asks us to imagine possible things. It asks us to hold our questions gently, to let curiosity guide us without needing immediate answers, to follow a thread of wonder into places where our intuition feels small, but our imagination feels limitless. Humans have always done this. Long before we had equations or telescopes, we looked up at the night sky and wondered what lay beyond the stars. We traced the motion of the moon and imagined unseen forces guiding it. We felt the wind and imagined the breath of invisible beings. Even if our early stories were not scientifically accurate, they were spiritually accurate. They honoured the feeling of living in a world far larger than ourselves. The idea of higher dimensions continues this ancient tradition of wonder. It does not diminish the universe. It expands it. It reminds us that reality is not a fixed box but a living landscape, a place with hidden layers, folded depths, and quiet secrets. It encourages us to ask brave questions. What if there are rooms in reality we cannot yet enter? What if there are laws we have not yet heard? What if our universe is part of a larger architecture woven through directions we haven't learned to imagine? Michio Kaku often speaks of this spirit, the idea that exploring higher dimensions requires humility and imagination in equal measure. Just as a flatlander must stretch their mind to imagine a third dimension, we must stretch ours to imagine the 10th or the 11th. It is not about believing without proof. It is about allowing ourselves to wonder where proof might someday lead. Wonder has always moved science forward. It drove our ancestors to sail past the horizon. It drove Galileo to point a telescope at the sky. It drove Einstein to dream of riding on a beam of light. And it drives physicists today to imagine the architecture of dimensions beyond perception. You carry that same spark, the ability to look at the world and feel that it is incomplete, not in a disappointing way, but in a beautiful, open-ended way. You sense quietly that there is more to the universe than the surfaces you can touch. And that sense is valid. It is the beginning of every great journey. As you breathe softly tonight, let yourself feel the freedom that comes with not knowing. Feel the serenity of exploring ideas without the pressure to solve them. Feel the calm of drifting through possibility, letting curiosity stretch gently into the darkness. Beyond the edges of knowledge lies a vast, silent space, not a void, but a canvas. Not emptiness, but promise. You have the freedom to wonder, to imagine, to dream beyond limits. And sometimes that is where the deepest truths begin. We began this journey with a quiet wonder. Are there extra dimensions? A question that feels almost like a whisper, drifting at the edge of thought. Not urgent, not demanding, just curious. The way a child looks at the sky and asks if the stars go on forever. Now, after wandering through stories of koi fish and hidden corridors, after imagining curled spaces, drifting membranes and cosmic collisions, we return gently to that original question. Not to answer it conclusively, but to see how it has changed inside you. When you first heard the idea of extra dimensions, it may have sounded abstract, distant, theoretical, almost too large to hold. But now it may feel softer, more intimate, more natural, as if the universe was simply more layered than you once believed, like the surface of a pond hiding a sky, like a shadow hiding the body that casts it, like a melody hiding the instrument that creates it. Michio Kaku once said we are the fish, beings who spend our lives inside a three-dimensional pond, unaware that an entire realm surrounds us. Not because we lack imagination, but because our senses were not built to feel what lies beyond, and so the universe remains mysterious not out of cruelty, but out of geometry. To the koi fish, the surface of the water is not a limit. It is simply all the fish has ever known. To us, 3 dimensions are not a cage. They are simply the shape of the world we have learned to navigate. Returning to the first question now, after drifting through the possibility of membranes, higher dimensional symphonies, hidden curves, and infinite structure within every point of space, you may notice something different. The question no longer needs an answer, not because the answer is impossible, but because the beauty of the question lies in its openness, in the way it invites your mind to stretch gently beyond the familiar, in the way it softens your thoughts, loosens your boundaries, and gives you permission to wonder. Perhaps extra dimensions exist, curled into spaces smaller than atoms. Perhaps they rise above us like unseen directions. Perhaps they cradle our universe like a vast sea cradles a drifting island. Or perhaps the truth is stranger still, woven into mathematics we have not yet learned to read. But whatever the reality, your life unfolds gracefully within it. You breathe, move, dream, and rest inside a cosmos that is deeper, richer, and more layered than your senses reveal. Returning to the question now, are there extra dimensions? You may find your heart answering softly. There might be. And that possibility is enough. Because the value of the question is not in certainty, but in the calm expansion it brings. It reminds you that the universe is vast, that mystery is gentle, that not knowing is a form of peace. You began with a question. You return with a wider horizon. As this journey through hidden dimensions comes to a close, let your thoughts settle like dust drifting gently through a sunbeam. You have travelled far tonight, not in distance, but in perspective. Through stories of koi fish and curved space, through curled dimensions and drifting membranes, through the vast possibility that reality is deeper than anything your senses can hold. Now, in this final moment, we return not to answers, but to stillness. There is a quiet gift in mystery, a soft, calming generosity in not knowing everything. You do not need to grasp the entire architecture of the universe to rest within it. You do not need to visualize 10 dimensions to be shaped by them. You do not need to understand the full geometry of existence to feel at home under its sky. Mystery is not a problem to be solved. It is a landscape to rest within, wide, open, patient. Perhaps the universe contains extra dimensions, curled softly inside every point of space. Perhaps it floats upon a membrane drifting through a higher dimensional sea. Perhaps gravity whispers between worlds, and light traces paths carved by structures we cannot perceive. Perhaps each breath you take is shaped by rhythms unfolding in hidden corridors of reality. Or perhaps the truth is gentler still, that we are creatures standing at the edge of knowledge, looking out across the silent expanse, sensing that something beautiful lies beyond the horizon, whether or not we ever reach it. The tranquility of that possibility is its own kind of truth. As you lie here, breathing softly, Feel the world around you grow quiet. Feel your thoughts slow to a gentle drift. Feel the space in your mind expand, like a night sky widening with every exhale. You do not need certainty. You do not need conclusions. You need only the comfort of knowing that the universe is vast, and you are part of it. Every star you've ever seen, every atom in your body, every moment of your life is woven into a cosmos built from laws and dimensions that flow far beyond your awareness. And yet, you belong here naturally, a quiet thread in a larger tapestry, a note in a cosmic symphony, a moment of consciousness in a universe that is still unfolding. Let this bring you peace, that you're not meant to carry the entire universe in your mind. You're meant to rest within it, to feel its presence, to drift gently through its wonder. And so, we end where we always end, not with certainty, but with calm. Let your breath follow its slow, steady rhythm. Let your eyes grow heavy. Let the mystery of the universe hold you the way gravity holds planets in their orbits. Softly, continuously, without effort. Everything flows. Sleep in that motion.